LIGO India. Where it is coming up? India. फिर इंडिया ही बोल दो. महाराष्ट्र में कहाँ? Where? Hingoli district. Maharashtra people should at least answer this. Hingoli district. A specific place on AUNDH. I will be asking one simple question if I get the opportunity to frame the question. Which particular agency of Government of India is involved in the implementation of this project? Department of Atomic Energy. Along with whom? National Science Foundation of US. Remember this. Again, same point, specification. LIGO, obviously, what is the operating principle of LIGO? Laser Interferometer Gravitational Wave Observatory. Where else these LIGOs are? Come on. Those who have attended the class last year. Louisiana, Livingstone, Hanford, Washington, Germany, Japan, Italy, and obviously next. But if you see, along with National Science Foundation, it is the first outside US. Please see the language of that. Those are not the involvement of the National Science Foundation of US. Just a brief introduction to gravitational waves. I will not be spending too much of a time. The concept was given by one person, okay, Albert Einstein in 1915. Okay, detected on, when they were detected? 15 September 2000. Where? 14? Okay, that's where you see exact, no 15. It was like 14 September 2015. And that is exact 100 years later. What exactly gravitational wave is? Like just, I'll give you an analogy. It is like this. See, for example, you are holding an iron ball, say this big, solid ball. And those people sitting at the back of the class, those sitting in the middle and those sitting in the front. And you are standing here. And you have simply dropped that ball. What will happen? You will feel those vibrations, isn't it? Those vibrations are gravitational waves. So they are the distortions created in the space-time because of some cataclysmic event, huge. The observable, just again here, the observable means something which we can feel. Gravitational waves are because of some massive thing. But you know what? As per the theory, when these two markers are being moved like this, they are also producing gravitational waves. But their mass is compared to those black holes. One was having mass 36 times the mass of a sun, and the other was having mass 29 times the mass of a sun. And when they were spiraling around, you can imagine the momentum. And when they simply had that booming sound, 6 times the energy of which is equal to the mass of sun was released in the form of energy. 6 solar masses were released in the form of energy. Just imagine the vibrations that will cause. Those vibrations were felt on 14 September 2015, where Hanford and Louisiana by LIGO. Is this clear? So that is what we call as gravitational waves. Just brief. So any two mass, yes. Observable, it has to be huge. What will be the relevance of gravitational waves? The relevance of gravitational waves where your Hubble or James Webb will fail is that they will not use any electromagnetic radiation. And when they will not use electromagnetic radiation, they will help us in understanding something known as black holes. Because black holes, you can't use infrared, ultraviolet, microwave because they will not allow that to come back. And when they will not allow it to come back, obviously you will not receive any information. And when you will not receive any information, obviously nothing is going to happen. This is what's the utility. Just one more point. Electromagnetic and gravitational, as I've discussed in the previous classes, they are always going, gravitational waves are always going to be weaker than the electromagnetic radiation. That's simple. That's simple. That if you like, it is very much like this. Piece of iron on the surface of Earth, magnet, it will pull upwards. That means electromagnetic is stronger than the gravitational. Otherwise, those pieces would never have come upwards. So, but just brief. LIGO. What is LIGO? It is an L-shaped structure. Are we going to follow the same model as it is there in Hanford? Yes, exactly same approach. What is the operating principle of LIGO? I hope I'm not going too fast. The operating principle of LIGO is interference. That is why interferometer gravitational wave observatory. What they are looking, obviously, in Hingoli, what they will do, they will have two L-shaped arms this way. Each will have exact same length, 4 kilometers. This is the same thing which is there in LIGOs over there. Fine. They are going to have the mirrors at the ends, M1 and M2. Okay. Then there is a source of laser over here. And then there will be a beam splitter. Beam. It will split that beam. Okay. Same thing. I'm just repeating it, consolidating it because there are some fresh faces also. Laser will be released, and laser will be released in such a way that there is a destructive interference. Destructive, not constructive. Constructive will not serve the purpose. Okay. So it will split. One wave will go in this direction, other will go in this direction. What will happen? As the length has to be same. If length is not same, it will not give you the result. That's why 4 kilometer, 4 kilometer. Measured to the level of angstrom. Okay, it's not broadly 4.1 or 3.9, then the job is not done. Okay, fine. As there is destructive interference, the light will be reflected. Speed is same, distance is same, so time will also be same. Am I right? Speed, distance, time. They will come back at the same time. As there is a phase difference, there will be destructive interference, and there will be no detection. This is photodetector. There will be no detection of light. When no detection, no gravitational wave. What is the feature? I hope things are making sense. This is a bit technical. See, what is the feature of gravitational wave? The feature of gravitational wave is like this. Just imagine you are having a football and filled with air in this case. You are pressing that ball. So obviously when you are pressing in one direction, the radius will reduce. Am I right? And in a direction perpendicular to that, the radius will increase. Yes or no? Same thing happens with gravitational waves. The direction in which they are traveling, in that direction, Earth will be slightly elongated. Slightly means few centimeters, or even millimeters. And in the direction perpendicular to that, it will be slightly compressed. That's why these two arms are at right angle. If it is traveling in this direction, then the length of this arm will be slightly elongated. Am I right? Yes or no? And the length of this arm will be slightly compressed. Now in this case, speed is same, but the distance is not same. Speed of what? Speed of light. Is it okay? Okay. When the distance is not same, obviously this is covering bit more distance. This is covering bit less distance. So this ray will be reflected earlier. It will reach at the destination earlier, and this one will miss the bus. So obviously that's again. So what will happen? There will be no destructive interference. When no destructive interference, this light will be detected at here. That is how LIGO works. I'm repeating. Some of you are staring at me. Listen here. What they wanted to do? They wanted to detect gravitational waves. How? By using the principle of interference. For what is the case? What is the requirement? L-shaped. Why L-shaped has been used? First, this is the question you have to ask me. L-shaped, they could have taken H also. No. And no. The arms have to be perpendicular. Why? Because if a gravitational wave is traveling in one direction, then in a direction perpendicular to that, there will be slight compression, and the direction in which it is moving, there will be slight elongation. That's why it has always to be perpendicular to each other. Is this clear? First, why they have to keep the length same? They have to keep the length same because if there is no gravitational wave, no, means no change in the length. Yes or no? That means the light will come back at the same time because distance is same, speed is same, the time is also going to be same. Then there will be destructive interference. You will not observe any activity here. But because of, say, gravitational wave, this arm got increased by delta L, and there was reduction of delta L over here. This is it. I think I've done my job. Here the light will travel a bit more distance. Here it will travel less distance. So obviously this one will be reflected first. It will arrive at the destination first. But this one is not here, so there will be no destructive interference. For that, overlapping must have two things. The second one is not there, it is late. Why? Because it is traveling greater distance. So obviously what will happen? No interference, and you will feel it. That is how the LIGO works. That is laser interferometer gravitational wave observatory. In the worst case, he will be asking the principle behind the working of LIGO, and just search one word over there, that is interference. Okay,